Hello everyone. So today we will see comparator. What exactly mean by comparator? So as far as this operational amplifier is concerned, you know that the operational amplifier. Just a minute, I will take the pen. Okay. So operational amplifier is concerned. There are operational amplifier two kinds of operational amplifier. That is configuration. That is nothing but my open loop and closed loop. So what exactly mean by open loop and closed loop? Suppose this is my operational amplifier like this one, and it is having two inputs. So the part this is my output. Operational amplifier output. This is my output. So operational amplifier has two inputs, inverting and non-inverting. If I'm feeding my some part of output to my input, that is nothing but I am taking the closed loop. So this is nothing but my closed loop. And if I'm not taking any kind of input from my output, that is nothing but my open loop configuration. So open loop configuration is having a gain of infinite. Okay, infinite gain is there. Open loop having infinite gain, and closed loop depend on which configuration you are using. That is nothing but open loop. That is nothing but inverting or non-inverting. So this is all about the comparator. Sorry, the configuration. And in if you are using operational amplifier in the open loop, the best example is nothing but my comparator. So in this video, we will see what exactly mean by comparator. So if you are not subscribed my channel, please go through the subscription. Then you are getting the latest update of you each and every video which I uploaded on my YouTube channel. Right. So what exactly mean by operational amplifier? We know that. So comparator. For example, I am having suppose two voltages like I'm having 2.5 volt and 1 volt. So which voltage is greater than? Which voltage is greater than? Obviously my 2.5 is greater than this one. And if I'm giving 1 volt at one pin and 2.5 to the second pin, which one volt is greater than? Again this pin. So the comparator circuit will compare these things, which is having greater output, which is having greater input. I'm saying sorry, greater input. So if this is nothing but my operational amplifier, right? This is inverting, non-inverting, non-inverting, inverting. Suppose if I'm having 2.5 volt at and 1 volt at this terminal. So as far as this operational amplifier is concerned, my output switch between either plus V set or either minus V set. Okay. So comparator will compare this thing. Means which variable is greater than inverting or non-inverting? Obviously non-inverting because it is 2.5. So it will give the output as plus V set because we know that output my output is nothing but gain into input. Okay. Is it clear? Get it input because we know that gain is nothing but my output divided by input. Output divided by input. From this I will say that output is nothing but gain into input. Yeah. So the gain is infinite and input is suppose very small, that is nothing but 0.00000001 also. Still you are getting infinite because infinite into anything will get you infinite rather than zero. So you will get the infinite. But infinite voltage you are not getting. We are getting voltages plus V set or minus V set. So what exactly mean by plus V set and minus V set? Suppose for example, if I am giving 15 volt positive volt and minus 15 volt as input. So the saturation voltage is near about this 15 volt and minus 15 volt. So the output, if my non-inverting greater than inverting, I will get the plus side near about 15 volt, near about less than that one. And if my inverting, that is nothing but second case like this one. If I am giving 1 volt at this and I will give 2.5 at this. So which voltage is greater? Obviously inverting voltage is greater than non-inverting. So I will get the output as minus V sat. What I will get is minus V sat. So I think this comparator working is clear to you now. Okay, clear to you now. So again, the comparator work in the two configuration. That is, input is given to inverting and non-inverting itself. So if comparator is having feedback, the circuit is called as what? Positive feedback. The circuit is called as what? Smith trigger. It is called as what? It is called as Smith trigger. So we'll discuss about this thing in later on lectures. So op-amp as comparator. So output is nothing. We have discussed this thing. Op-amp output is nothing but gain into voltage at this terminal, inverting, non-inverting minus voltage at inverting terminal. So we have discussed about these things. So this is all about it. So this is all about the voltages. Suppose I'm having one voltage as a reference as a 0, one voltage at 0 level, and one voltage is AC voltage. So if my op amp, suppose these are the two pins are there. These are the two pins. So what I will do, if I'm drawing like this one, waveform is like this one. Just a minute. So I will draw the diagram and I will explain the things to you in detailed manner. So just a minute, I will take pen. Okay. So as far as op amp is concerned, there are again two inputs. I will say. Okay, this is my VCC. This is my minus VE supply, and you are taking output at this level. Okay, there are again two inputs. So if I'm giving input at 2.5 volt over here, and I will give 1 volt. So which one is greater than? My inverting, non-inverting, non-ion inverting is greater than inverting volt. If such case will happen, then my output is plus Vset, because whichever is greater, non-inverting, so we will get a VCC. That is nothing but the Vset volt. And if my inverting is greater than non-inverting, then I will give to minus Vset. So you have to keep in these things in your mind. So if I'm drawing like diagram like this one, okay, like this one, and my input is this one, sine wave at inverting configuration. So I will say this thing as input, and the second voltage I will say it is as reference. Okay, and I'm taking output at this terminal. So if I'm taking the if I'm drawing the graph of the particular thing, then what will happen? Graph of this thing, then what will happen? So this is my input. Okay, this is my input. This is my input. Then what will happen? The voltage, if the this is my reference voltage, I will say reference voltage. So if my reference voltage is plus 2 volt, I will say plus voltage, I will say. So if this is the plus reference voltage, what this is my reference voltage, V reference, I will say, and this is my input. So what will happen? So from this thing up to this, because this is the cutting point. So in this case, my input, which is I have given to my inverting terminal, is less than my reference voltage. So reference voltage is greater. So from this point to this point, my reference voltage is greater. So my output, will draw the waveform of output over here. So in this case, up to this point, my non-inverting is greater. So I will give the voltage as plus V sat. Okay. From this point to this point, my inverting voltage is greater than my non-inverting voltage, so the output will be switch from plus Vset to minus Vset. Okay, up to this point, because the inverting is greater than non-inverting up to this point, so I will get a minus Vset over there. Again, from this point, again this is positive voltage. V reference is positive voltage. That is non-inverting is greater than my inverting voltage because it is in the negative again. So from this point to up to this point, which is greater? My non-inverting reference. So again my output will be plus V sat. Output will be plus V sat. Again from this point, this will change to minus V sat up to till this point. So likewise my output will be changed. If my reference voltage is more one, though this voltage will be less one, more one again. Okay. So like this one, I have drawn the waveform of comparator with comparator. Which comparator? I have given input to the inverting comparator. So inverting comparator with positive V reference. Positive V reference I have drawn to you. So I think this concept got to you. So I think I will stop over here. In the next lecture we will see the inverting amplifier with the negative V reference supply. Then we will go for the non-inverting comparator with positive V reference and negative V references. So this we will see in the upcoming lectures. So thank you very much.